Hi there, so in this video we're going to continue with examples of partial fraction decomposition. So the first thing that we have this example here is make sure that the degree in the numerator is smaller than the degree in the denominator. So this, we have a quadratic in the numerator and a cubic in the denominator. So we're good. We can possibly do partial fraction decomposition. The next step is, in order to really see if we can do partial fraction decomposition, is to check that the denominator factors. So can you factor this? And I do have 4 terms, so we're going to try factor by grouping. Anytime you have 4 terms, try factor by grouping. And so the first two, notice that they have an x cubed and an x squared, so I can take out an x squared. And I'm left with 2x minus 1. From the 8x and 4, 4 goes into both of those. And because that is a negative, we're going to take the negative out. So I'm going to say minus 4. And I'm left with 2x minus 1. And so now notice that we have the 2x minus 1 that's common. So it'll be 2x minus 1 times x squared minus 4. Now notice that x squared minus 4, that's a difference of squares. So this we can continue factoring to 2x minus 1, x minus 2, x plus 2. So yes, it does factor. So we have the degree in the numerator is smaller than the degree in the denominator, and the denominator factors. So we can write the partial fraction decomposition. So I have 3 different factors. So this possibly came from 3 different fractions. So I have my 2x minus 1, x minus 2, and x plus 2. And because these are all linear, then I'm going to have just constant terms in the numerator. Again, in my previous video, we talked about if you have a quadratic and that came from an irreducible quadratic, then you will have a linear above, which will be mx plus b, but just kind of follow the pattern of your letters. And if it's a repeated factor, then you leave it as a constant term. So the next step is multiply by the LCD. So let me go down to the bottom. Well, I'll do it here. And so multiply by the LCD. So the LCD is going to be the 3 factors. So 2x minus 1 times x minus 2 times x plus 2. And we do it on both sides. So here I'm just going to get a little lazy and say LCD. And so the whole thing will cancel. When I multiply, I'm going to have 9x squared minus 9x plus 6 equals, when I multiply these out, the 2x minus 1 is going to cancel with the 2x minus 1 here. So I'm going to be left with a times x minus 2, x plus 2, plus, and then when I multiply the LCD by b, the x minus 2 is going to cancel. So I'll be left with b times 2x minus 1, x plus 2. And when I multiply it by the last term, the x plus 2 is going to cancel, but these two will remain, so it'll be plus c times 2x minus 1, x minus 2. And now we go through and solve. Our goal, remember, is to solve for a, b, and c. So this one is looking a little daunting. But this is where the choosing zeros method works really nicely. So I'm going to do the choosing zeros. And so what makes any of these 0? So notice that 2, -2, and that one we have to do a little more work. So I'm going to start with 2 and -2. So let x equals 2. And remember, for this, you plug it into everything. So when x is 2, I'm going to have 9 times 2 squared minus 9 times 2 plus 6 equals, now when x is 2, the x minus 2 is going to go away, so the a is going to go away, so I'm going to have a times 0. What else goes away? When x is 2, essentially the x minus 2 term, so I have an x minus 2 here, so plus the c, or I'm going to get a 0 there, when x is 2. But this one, is going to stay. So it's going to be b times 2 times 2 is 4, minus 1 is 3, and 2 plus 2 is 4. So what do we have here? So 9 times 4, that's 36 minus 18, so that's 18, plus 6, so I'm going to have 24 equals, the A is gone and the C is gone, so I just get 12B, which tells us that we divide both sides by 12, B is equal to 2. And we have our first constant. Now let x be, choose another 0. So negative 2 makes x plus 2 0. So let x be negative 2. So when x is negative 2, which ones are going to go away? The A is going to go away, and the B is going to go away because I have an x plus 2 there. But we still have to plug it into the left. So I'm going to have 9 times minus 2 squared minus 9 times 2 plus 6 equals, now when x is minus 2, the A is going to be negative 2 plus 0, so that goes away, and the B is also going to go away because I'm going to have negative 2 plus 2, which is 0. So the only one that doesn't go away is the C. So I'm going to have plus C, x is minus 2, so 2 times minus 2 is negative 2, minus 1, that's negative 5, and negative 2 minus 2 is negative 4. So we're left with, let's see, 9 times 4, so that's still 36, positive 36. Oops, and that's a minus 2. So minus 9 times minus 2 is positive 18, so I have 36 plus 18 plus 6. So usually I do 18 plus 6, and that's 24 plus the 36, so that will give me 60. So 60 equals negative 5 times negative 4 is positive 20, 20C. Divide both sides by 20, so 3 is equal to C. So far I have B equals 2 and C equals 3. So now we need to find A. And so we can choose another 0. So what makes 2x minus 1 equal to 0? Right, 2x minus 1 will be 0 when x is positive 1/2, but now I have to plug in fractions into here, so that might not be the best course of action. So one of the things that we can do is, in this case, we can kind of combine terms or combine methods where I can use the equating coefficients method with the choosing zeros method, since I already have two of the variables, of the constants that we're looking for. So I'm going to go back up here to my 9x squared minus 9x plus 6, and I'm going to multiply these out, not entirely. I'm only looking for A, so I'm going to just figure out what my coefficient will be for the x squared term, and I'm going to use that 9. So if I was going to multiply it all out, and let me try to copy it. Okay, so keeping in mind that we're looking for A, so what I'm gonna try to do is just figure out the coefficient. I'm gonna equate coefficients for x squared. So I want to be able to say 9 equals something for the x squared term. So if we were going to multiply everything out, what will the x squared term be here? So let's see. If we multiply this out, the x squared term is going to be just x squared. So I'm going to have ax squared plus other stuff. And then I'm going to move on to this one. I'm only going to do, since I already have B and C, I'm only going to look to find A by equating the quadratic coefficient, because that's my easiest one to find. So for B, I'm going to have 2x times x, so that's 2x squared times b, so b plus 2b x squared, and then b times the rest of the foiling, which again I don't need because I'm just looking at the x squared coefficient. And I'll do the same thing for c. So for c, I'm going to have 2x times x, so again it's 2x squared times the c. So I'm going to have plus 2c x squared plus the other stuff that follows after I FOIL everything out. Again, I'm only looking at the x squared term, and so now I can see that then 9 is going to equal to a plus 2b plus 2c. So I already know b is 2 and c is 3. So I'm going to have 9 is equal to a plus 2b plus 2c, and b is 2 and c is 3. So we end up with 9 equals a plus 4 plus 6. So 9 is equal to a plus 10, which means that subtract 10 from both sides, a is equal to -1. And so now we have our 3 constants. So that means that a is equal to -1, b is equal to 2, and c is equal to 3. And therefore, we can write the partial fraction decomposition. So our original problem was 9x squared minus 9x plus 6 divided by 2x cubed minus x squared minus 8x plus 4. Now I can say this came from the fraction -1 over 2x minus 1 plus b, so 2 over x minus 2 plus c over x plus 2, so c is 3, so 3 over x plus 2. And we make sure just that was the original partial fraction that I had 2x minus 1, x minus 2, and x plus 2 when we set it up. Yeah, 2x minus 1, x minus 2, x plus 2. So a is the one above 2x minus 1, so -1 over 2x minus 1. And so that is the partial fraction decomposition. So choosing zeros is one quick way to do certain things. And sometimes if you don't want to, like in this case, we didn't necessarily want to deal with the 0 being 1/2 and having to plug in a fraction into our entire equation, then you can mix the methods by combining coefficients, but also choosing zeros. Sometimes choosing zeros gets you to a constant, to the value of a constant much faster, but sometimes you still have to resort to equating coefficients just to solve the rest. Okay, I'll post some other videos as well for the reducible quadratic factors and repeated factors.